Hello everybody, Dr. P here. In this video I will cover Math 20-2 Proportional Reasoning, Topic 4, Example 2 on page 37. Alright, we are going to be calculating or determining the surface area from scale factors. Okay, in A baseball has a surface area of 176.7 square centimeters. The diameter of a soccer ball is 2 times the diameter of the baseball. What is the surface area of the soccer ball to the nearest tenth of a square centimeter? Okay, so we need to read these sort of questions really carefully because the term diameter here refers to a linear dimension. Okay, so when we say that the diameter of a soccer ball is 2 times the diameter of a baseball, it means that the 2 here is a linear scale factor. Don't get confused by the fact that it talks about surface area. Diameter is not an area or surface area, it's a length. Anytime we talk about a length, we're talking about linear scale factors, okay, or the linear scale factor. All right, so what we need to do here is we need to we want to use the surface area scale factor to determine the surface area of the soccer ball. Okay, in this context, we're going from the baseball to the soccer ball, which means that the baseball will be our old or our original object, and the soccer ball will be the new one. Okay, so the formula we're going to be using here is surface area scale factor equals the surface area of the new one, so that's going to be of the soccer ball, divided by the surface area of the old object, which is our baseball. Okay, and so in this equation here, we can determine what the surface area scale factor is because we have the linear scale factor. We also have the surface area of the baseball, it's right up here, and we're looking for the surface area of the soccer ball, the new object. Okay, so let's plug in what we have. Well, actually before that, we need the surface area scale factor. So the surface area scale factor is just the linear scale factor squared. That means we can plug in our linear scale factor, which was 2 squared, which means that our surface area scale factor is going to be 4. Okay, so that's actually sort of step number 1. Step number 2, now we can plug it in here. So the surface area scale factor is 4. Okay, we are looking for the surface area of the new object, the soccer ball. We know the surface area of the old object is 176.7 square centimeters. All we have to do here is multiply both sides by 176.7. And on the right hand side, 176.7 divided by 176.7 just cancels. And we're left with surface area of the new object equals 4 times 176.4, and if we calculate that, the surface area of the soccer ball is going to be 706.4 centimeters squared. That's our answer here. All right. We have question B here as well. The greenhouses at the Mutard Conservatory are each in the shape of a square pyramid. An architect has a model of the largest greenhouse. Okay, so he has a model of the largest greenhouse. The model has a glass surface area of 1.15 square meters a linear scale factor of 40 needs to be applied to the dimensions of the model to produce the largest greenhouse. What is the glass surface area of the largest greenhouse at the Murtagh Conservatory? Okay, so again, we're going to be using this formula, surface area scale factor equals surface area of the new object divided by the surface area of the old object. Okay, now in this context here, the old object is the model. Okay, the new object is the actual greenhouse, the real greenhouse, the actual greenhouse. Okay, we have a linear scale factor, but we need a surface area scale factor. So all we have to do is, to get the surface area scale factor, is to square the linear scale factor, which means that our surface area scale factor is 1640 squared. Okay, we can plug in what we have. So it's going to be 1600 equals to, and in the numerator, well, that's what we're looking for. So we're just going to put the surface area of the new object. We know the surface area of the old object, the model, is 1.15 square meters. Multiply both sides by 1.15, and we're going to get a surface area of the new object of 1.15 times 1600. And if we multiply that out, we're going to get 1840 square meters. Don't forget the units. Okay, and that's a wrap. Until next time, stay safe, stay healthy, and may the math be with you. See ya.